On to positive light. So this is when the sun is in front of the viewer. So let's draw this again. Here's Earth, and then the viewer is standing here, and put a little hemisphere, like being in a snow globe. And if you're looking straight ahead this way, put a line along the floor, and here's the line of sight. And so this is 90 degrees between where the viewer is looking. And if the sun was along this path, then this is the parallel light, where the ground line and the light angle would be parallel to the picture plane. So there's no vanishing points for the light angle or the ground line. But if the sun is in front of this, anywhere in front of this, this would be considered positive light. And if the sun's behind the viewer, a negative light. So normally, now it's just done something like this. Here's a horizon line, here's like 3 sticks. And we just like find a place to put a ground line vanishing point. So now the ground lines will have vanishing points. And the vanishing points for those will be on the horizon line. So there's a kind of a dot already there. We'll make that one the ground line vanishing point. And this is just like a vanishing point, like any other vanishing point. It's just a dot that draws lines that go along the floor. So the shadows, if this is the ground line vanishing point, then the shadows of these sticks go this way. Easy. Now, the light angle is what cuts them off. The light angle gives you the length of the shadows. The ground line gives you the angle of the shadows. If I put this ground line vanishing point right more in the center, like closer to where the center of vision is, if I put it right on the center of vision, then you are looking straight in the direction of the sun. So let's put the light angle in here. So there's just really one thing to remember with this light angle, that it is directly above the ground line vanishing point, 90 degrees from the horizon line. It could be anywhere like along this line. The farther away it is, the shorter the shadows are going to be. Just the higher it will be up into the sky. And the closer to the horizon line, the longer the shadows will be. And if you don't really care, like you can just pick out a spot, and this will be the light angle vanishing point. And so this is where the sun is. And from here comes the light angle, and that goes from the top of this stick, and it tells you how long the shadow is. So most of the time, it's like an aesthetic choice. And unless you put that light angle vanishing point like pretty far away, you are going to get some like really long shadows. And when the light angle vanishing point gets really far away, it's also a little awkward because it's really far away. You have to have a really long ruler. So we could probably do better than this, or get a little more specific than this. Like, I'm not exactly sure why you'd want to put the sun at a really particular spot up into the sky, but maybe if it was like a really particular, like very specific scene that you were drawing, and you wanted to display the shadows from a particular time of day, we can do that. So get back to this one. So this is where the viewer is looking this way. So the sun, positioning the sun into the sky is a matter of degrees. The last time we did it, we had the sun 90 degrees from where the viewer is looking along this line. And the viewer's looking like straight ahead here. So there are 90 degrees to the left of where the viewer is. There's 90 degrees to the right of the viewer, and we could just pick out any spot like along here in degrees from where the viewer is, from where the station point is, degrees to the left, and degrees to the right. So if we had, for this, we need a little more information in our layout. So we need to know like where the center of vision is, where the station point is. And these are all degrees to the left and degrees to the right. I mean, you could put a protractor down here and like do it that way, but I'm just gonna use a triangle that here is degrees to the left, degrees to the right of where the viewer is looking. So let's say I don't know. Let's make the sun 45 degrees to the left of where the viewer is looking. Here's 45 degrees to the left. So this will be my ground line vanishing point. The shadow is heading this way. Now I want to put the sun at a specific degree into the sky. If the sun is directly overhead, then it's going to be right here, 90 degrees from the ground. And in this position, you don't get too many shadows. So let's see, we went over 45 degrees to the left, so let's just make a dot right there and say that's 45 degrees to the left. And so here's degrees vertically. So this would be 90, and this is like 0. So we could put in degrees, like put the sun up into this position, just about anywhere we want. This is where it gets a little bit trickier. It's a little trickier than just like we just got to do the 45 degrees over to the left to get that spot. To get the sun 45 degrees above the horizon line, well, we know that it has to be aligned with this, right? So, well, actually, let's not do 45 above the horizon line. We did 45 to the left. Let's do 30 degrees above the horizon line. So 30. But we can't just do this. This doesn't really make any sense anyway in this diagram. So this is just like a vanishing point, really just like any other vanishing point. It draws lines that are at a 45 degree angle to lines that go to the center vision. So to make a line that is at a 30 degree angle to the ground, we need a point where we get our true angles from. And this slight angle vanishing point up here, this works just the same as an auxiliary vanishing point, right? When we did inclines. In fact, like, see, this is just an incline. What is the video? If you look back at videos, I think it's like 63, I think, or around there, we talk about drawing inclines. And this ray of light, we can, well, I was going to say turn it into an incline, but it is an incline. Like if you did this, we could just like make this like a road. And there you're driving down and then going up the street and then flattening out. We did a video like that a while ago. So, but instead of being a solid thing, it's just like a ray of light. So to get our auxiliary vanishing points in a really particular place up in the sky, we use the measuring point for that. So what we need is like a measuring point for this ground line vanishing point. So to do that, you take this distance from the ground line vanishing point to the station point. You take that and swing this up. This would be, well, if we're drawing a physical thing, this would be a measuring point for this ground line vanishing point, but we're not really using it as a measuring point, so I don't kind of like calling it a ground line measuring point, but I don't have a better word for it. It kind of relates back to what the measuring points are for. which is true angles. One of the things they do is give you true angles for inclines. So I'm going to just stick with this and call it a ground line measuring point, even though we don't use it to measure anything with. What we use it for is to get our true angles. So if I wanted the light angle vanishing point to be 30 degrees above the horizon line, you wanted the sun to be 30 degrees above the edge of the earth, then I come over here and take this and make a true 30-degree angle. And this is where my light angle vanishing point is. This would be the sun. And then my light angle comes from here through this. And there's the end of the shadow. So everything else about it is just the same as with the parallel light. As far as all the rules go, shadows of vertical line, shadows of horizontal line, shadows of incline, shadows on curved surfaces, shadows of curved things. It's all the things we did with the parallel light, it applies to this. But I don't know, maybe we could do one or two samples using the positive light and draw things that are not like just sticks. So maybe next time we do that.